as you're looking at that, we don't have that whiteboard filled out, but this gives you somewhat of an idea. It's kind of bright if you're looking at this, if you're not here today. But again, we'll talk about the fractionating tower and how petroleum is, let's say, not manufactured, but split, I think, or better, not harvested either, but separated into its various units. We'll talk about that today. Okay, start talking about some common polymers tomorrow. Okay, we'll finish this chapter then on Wednesday, and then start reviewing some problems, and then have a second problem quiz. Now, we will go over some reviewing of some of the, whether you call them simpler problems like alkanes, alkenes, and alkynes. We'll go over them towards the end of the period today. So I just want to give you somewhat of an idea, since it's not over there, so that you can look and see, okay, this is what we're doing, because we're still here for this class period, but some of you will be gone on this day, correct? On Thursday for your conference meet, correct? And is that in DeSmet too, or is that going north? Okay. And I think you leave a little earlier. I'm thinking 10:30, perhaps. If that sounds right. Maybe yes, maybe no. But I do think you missed this class if you are in track. Okay, so that gives you somewhat of an idea on where we're going in regards to this week, and how the rest of the semester is starting to wind down. Okay, picture this could be one of those aspects. Some of you are working really hard to maintain where you're at. Let's not get it to let's say first and goal and then fumble on the goal line, or work so hard that lose our concentration towards the end. And it's human nature to have that happen. So if you have any problems, please get in and talk to myself. That is your opportunity to do so. So again, that just gives you somewhat of a general idea on what it is we're doing this week. Okay, so as we proceed forward with this here. Okay. So when we've been going over these compounds, what did it mean by reverse engineer? What would we say? What would we put in a box? Or we'll save that for later. We'll skip that. We'll come back. I don't want to be jumping around saying, well, we're doing this, we're doing that. Okay. But in other words, what is a substituted hydrocarbon? We know it's got hydrogen, we know it's got carbon. So what happens to one of the hydrogens? It gets replaced by what, possibly? A what? Either a halogen, so that's a halogen derivative, and that's what we're referring to here. Okay, so naming would occur from propane. So how many carbons is this? Propane. Yeah, how many carbons? Okay, oh yeah, not hydrogens, carbons. So in this case, one of those chlorines replaces a hydrogen, so you can call that chloropropane or propylchloride. Okay, so moving forward, we talked about this, and now petroleum. Okay, and we saw a video about this on how this petroleum goes through a fractionating tower and how it's separated out. Refined, that's the word I'm looking for. This substance has to be refined. Is it possible that we will run out of petroleum? Probably eventually. There are some fairly big reserves still located. I do believe one of the largest ones is still in North Dakota. Now, where that's at in the process, I'm really not sure. So, what's the first thing that comes to your mind when you think fraction? Like maybe that of a pizza. Okay? So, if you are given a whole frozen piece of pizza, or maybe you're a Papa Murphy's type individual where, what is it they say, we make it and then you bring it home and bake it. So once that's been baked, whether it's that, a frozen one, if you if you buy it from, let's say, Godfather's or Casey's, well, then they cut it for you. But the idea is, if you got this frozen pizza, unless you cut it, you're thinking of a whole one. And maybe some of you can eat a whole pizza. For those of you, when you do go off to college, I certainly remember Tony's Pizzas. You can get 10 of them for how many, do you think? For what price? 10 for $10. So how many of you could eat a whole Tony's Pizza? I think you probably could back there. Yeah. Okay. So then you, not that you'd have to cut it, but you probably would. So you take your frozen pizza out of the oven, and if you just cut it once across, now you've got what? Two halves. Okay? Cut it once across one way, you turn it 90 degrees and cut it across another way. So how many pieces do you have now? 4. So each one of those individual pieces is just a fraction of the whole. So that's what we mean by fraction, correct? You take one out, okay? That's 25%, and of course leaves you 75% left. So when we're talking about fractional distillation, we're talking about cracking all these different types of compounds, all of those individual pieces that would make up a whole, all right? And it's, how many carbons is it? That's up for debate, probably somewhere around 30 to 40 hydrocarbons. Then towards the end, that's more so asphalt and tar because it is just so thick. But in this fractionating tower, what is the simplest hydrocarbon? Methane. That's all. And how would you know that? It's only one carbon. Okay? So one carbon length, that is methane. That's the simplest hydrocarbon. So when these separated out, it's the lightest. So therefore, that's how this works. Since it's the lightest, it goes up to the top. Okay. And we'll illustrate this here in just a moment. down yet. Okay, does everyone have this information that wants it? Okay. You said we want to leave some time for review. So we'll pick up with how this happens tomorrow. Okay, so we'll look at that fractionating tower, what it is we're referring to. Okay, so again, we're taking this in a, hopefully you would agree, a slow progression, because one of the derivatives you're not responsible for is propyl groups and isopropyl groups, okay? That will be the next step in general chemistry for those of you who do take that, okay? So we try not to overwhelm you. It might seem like it, but again, if you have problems, please get in and talk to myself. We'll get you our best to get you straightened out. Okay, so what that had meant, if this is your fractionating tower, okay, you don't need to draw this. It's just try to illustrate what's actually happening here. So here's your building, and probably underground here, you'd have piping in of this crude oil. Okay, so it said has all these plates in here. Okay, and you got a furnace underneath that is heating that substance to probably somewhere around, was it maybe 550 degrees or so. You got a furnace down here that's burning. So you got your crude oil in here that's being heated, and you said, what is the simplest hydrocarbon? Methane. So carbons perhaps 1 through 3 might show up in here, but we got enough plates in here. So CH4, okay? Then the next one down, possibly C2H6 to C3H8, and so on and so forth. So somewhere here in the middle, you might have some nonane, which means how many carbons? 9. So this is going to be perhaps somewhere around kerosene, because here's what you see at the gas pump, okay, your gasoline. But that gas is mixed with what? Your octane is mixed with what, if you remember? 7 carbon compound, which is, and it's heptane. That's right. So that's why you see that little sticker that says 87 or 89 or 91. I suppose there's 92, but that's your high octane rating. That's just what it means. High octane, 92% octane and 8% heptane. All right. So as we proceed forward, okay, we said we wanted to show you ideas on how to, let's say, reverse engineer this. If we had something like this, 6, 7, 8, 9, okay, what's the first thing you're going to do with that compound? Find your longest continuous parent chain. Okay? So, well, is it 1, 2, 3, 4, 5, 6, 7, 8, 9? Is that the only way it could go? Or is there another way? Can it branch instead? Yes. It can go up and over like this. Here's 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So, What do you notice about all of those hydrocarbons? They are what? All of these carbons are bonded how? They're single bonds. So that means this is which organic family? It's an alkane, okay? And it's 9 carbons in length. What is the prefix for 9? Non, okay? Non means 9, so we've got our nonane, okay? So we've got 3 different derivatives branching off of this nonane, okay? So do you think, are we going to be reading this left to right or right to left? Left to right. So there's nothing wrong with going through here and saying on our third one, okay, we've got 3, 4, and 5. Because if we go the other way, we've got 4, we've got 5, 6, and 7. So that's why we're not going this way. Because remember, which sport are we referring to? Golf. You want the lowest combination. Okay. So, what are all 3 of these derivatives the same name? No, they are not. What are our different derivatives? Okay. So where's our ethyl group? Which carbon? Okay. So if you feel, you can put an E there if you wanted to. And then these 2 are what? Okay, when you do that, then you don't forget, well, what they are and where they're located. Okay, so the last thing you want to do is place them in which order? Alphabetical order. All right, so which will come first? Obviously, E or the M. Okay. We've got the dye we do not utilize in that. That doesn't count as far as the alphabet. I can't say that word. Alphabetization. Does that sound right? Okay. So we've got 3 what? Okay. And then what? This is where 4, 5, we want to name both of them dimethyl. Okay? So now we've accounted for all 3 of those. Okay? So when we reverse engineer this, we'd always put boxes around this just to show our organic family. Okay. That's your organic family. Correct? Are we nodding our heads yes? Okay. So that tells you your organic family. What does this tell you? The number of carbons you have. Okay. Up to this point, okay? Right outside. We on the bus. Middle. Left middle. Right middle. Left outside. Okay? So, if it's one of them things, if you're just saying this and it's really this, please make arrangements, okay? To come in and talk to yourself before after school. But before school, available. Give yourself a hand if you feel needed, if that is needed. Okay? So this says that there's a methyl group, but there's 2 of them. Where are they located? On the 4 and 5. Right there they are. 4 and 5. And this says there's an ethyl group, which is how many carbon derivative? These are 1 carbon derivatives. This is 2. So, and it's located on the 3rd carbon. Got a couple hydrogens on there. Okay? Can we erase this? Okay? What about isomers? Are we comfortable with isomers? Okay, just pick a number, 6, 7, or 8. I heard 8 first. Should have picked smaller ones, but that's okay. All right, so we'll go with 8. All right. So what is the formula for octane? C8 what? $18, right? Okay. For there's one above and one below. For those 8, that's 16, 17, 18. Okay. So what does it mean to be an isomer? Okay. We're still going to have that same formula. Okay. So what's the simplest way to make an isomer? But you got to be specific on where you put it. Where? Anywhere other than the end. Correct. Okay? So there's 7. So as I go left to right, you tell me when to stop. Okay? Above or below? Okay? So what should we put below there then? Okay? So a carbon with what? Okay, so how many total carbons is that? It's still 8 carbons. How many hydrogens do we have? 18. Okay? This is an isomer. It's not called the same thing. Okay? So what would this be called? It's now a 7 carbon parent chain. 2-methyl-heptane. Okay, so 1 and 2. This is a methyl group, so we got 2-methyl-heptane. Okay, our organic family, number of carbons in the parent chain. This says there's a methyl group, and that tells you where it's at. It's on the second one. Do we see the pattern that's arising here? Well, I don't know if we really call it a pattern, but I would hopefully look at it as a pattern. So alkanes, are we good with those? Okay, so how is an alkane different than an alkene? Okay. So pick a number between 5 and 10. 5, okay? So if it's 5 carbons, what compound are we talking about? Pent what? Pentene, okay? So if we just did this, how would we draw? It doesn't say anything about where that double bond is located. So it's after which one? After the first one. Okay, so we know we've got 5 carbons. Okay, so it's after the first one. Okay, so how many more hydrogens does this one get? It's got 1. You shaking your head? No. Why are you right? Yeah. It's double bonds, so there's 2, 3, and 4. It can't have any more bonds. Okay? So this still has a double bond. How many hydrogens does this get? Okay? So now, that is pentene. If you really, really wanted to be specific, you would say this. But it's not necessary. It's just understood that if you just say pentene, it's after the first one. Okay? Well, if we wanted to put a 1 there, how about this? Is that possible? trick question. It can't be 3-pentene. It has to be what? In case you're wondering, why would you do that? Trying to trick? No, it's not a. You might think it's a low down dirty trick, but we'll show you why that is the case. We still have 5 carbons. Okay. So what's happening after that 2? First, second, what's happening here? There's a double bond. Okay? So everything else is single bonded. So this carbon, how many more bonds can it have? It's got 2 and needs 2 more. This one's got 4, so he's done. 1, 2, 3, and 4. This one's got 1, 2, 3, and 4. This one's got 2, or 3, excuse me. 1 more, and what about this one? 1 more. Okay, so this again tells you organic family. ENE, that's an alkene. There must be a double bond located somewhere. It's 5 carbons in length, and it's after the second one. Because if we tried to do this, okay, so if you tried to do this, that looks like it could be 3-pentene, don't it? 1, 2, 3, it's after the third one, but again, what sport are we referring to? Yeah, that's why we get our phone out to Google. What is this? I don't know. That's just what it looks like. Maybe looks are deceiving. All right. So with that, what is? This is not 3-pentene. Did you get your answer? It was what? It was this, huh? Yeah. This, whatever you're doing is way more important than this. And maybe so. All right. So, does everyone understand why this does not exist? Okay. Middle. Left middle. Right outside. Right middle. Left outside. Okay? Because if you go this way, 1, 2, 3, remember we said you want the lowest combination. That's why it has to go here. This does not exist. It's the same as up above. All right. So, what do you think would be easier drawing for isomers? Alkanes or alkenes? It's a trick question. Just don't answer it just like that. It's actually alkenes are harder to do. Because there's more of them. Okay? The reason we say that is, okay, when we look at, can we erase this? Okay? Okay? So if we look at propane, for an alkane, can you draw any isomers for that? The answer is no. Why not? Because you correctly said earlier was take this off the parent chain and put a methyl group on there. Well, you're not putting a methyl group on that carbon. You're just bending it. It's still propane yet. Okay? So if we go up to butane, okay, what is the simplest thing you can do to form an isomer for that? Take that carbon off. Okay. And put what down here? Move him down to here. Okay. You went from butane to what do we have down here now? What's your parent chain? Propane. But what's branching off of that propane? right here on the second carbon. Okay? Are we good? All right. So, on the other hand, if you do alkenes, all right? So, for instance, that one. Can we just move that double bond to the other side? No, you can't. You're right, but why not? It's the same thing, okay? Because if we say, well, I'm just going to move the double bond to the other side, you still have propene because you're just going in the opposite direction. Okay. Left outside, you good? Left middle, 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 middle. Okay? Can't keep up with Liberty, can you? Because Liberty's on the move. You got to talk to your other agents. You must be falling behind. Other Secret Service agents. Okay. Left middle, left outside. Okay. So on the other hand, if we talk about butene now, this is a little more difficult, okay? So what you could do is this guy. Then you could also put a methyl group on there, but we're not going to go in that far in depth right now. Okay. So the last thing I want to do, and then the rest of the time will be yours. Okay. Okay, what's the first thing that comes into your mind when you see that? There's a lot of things that could come into your mind. Like parent chains is what? Is 2. You're right. Why? Okay, because it begins with this, so we can safely put 2 carbons. Okay, so this suffix, that's your organic family, which means what? It means acid, but what is the formula for that acid? Double bonded oxygen. Okay, left or right side? Okay, so you said double bonded oxygen, and what else? Combine what you said, and you said, and you said. Because you all said the same thing, just in a different way. Okay? Because they never said it in that, I don't think. Did anyone else say coo, C-O-O-H? Hey, but you never pronounced it as coo. You just said C-O-O-H, right? Yeah. Okay? So what that means, okay, that coo, C-O-O-H, that's what they're referring to. When you have a double bonded oxygen and an OH, that's your organic family. Okay? And then it's 2 carbons in length. There they are. And here's your organic family. It would still be the same if you had pentanoic acid. You just have COOH, but only 5. You'd have 5 carbons instead of 2. Okay? The prefixes are still the same. All right. Barring no questions, left outside. Okay, left middle, middle, right middle, right outside. So again, if you have questions, please get in and talk to myself. Okay, we'll catch up to you next time.